This review of this data brief, as you'll see, looks very similar to all the rest of the data briefs that you have seen, and again will look similar to the data brief that you produce with your team. So it begins with the key findings here on the left. If you use the bookmarks, you can see where they answer each of their questions. And then it begins with an introduction, a general question, so asking about total high cholesterol, a response, and a graph. And if you look at it again, we then have another question, a response, and a figure. Question, response, figure. Question, response, figure. Question, response, figure. So this is how all of the data briefs look, and this is how your data brief will look. So let's look at the question here. The first question here is the percentage of women with high total cholesterol is higher than the percentage of men with high total cholesterol. So you can sort of look over here and see what the percent of general is. This looks at men, women, and total. And so you can see here, it's broken down by age. But then you can also take a look here in this paragraph that talks about a total percentage of men than women. So this is where you can find that answer. So you really do have to read the data briefs. It can also be helpful to search them for keywords, again, using the edit find function. And so you could search high for high total cholesterol, and it would walk you through every place that was mentioned. And then you can make the assessment there. So for question number 2, it's asking about the percentage of men with low compared to HDL compared to women. So you'd look for that in the same manner. This data brief is informative, but you want to do a more refined analysis. And by the way, this is what happens with grant submissions, is that you'll go in search of somewhere that has data that might be similar or representative of what you'd like to do in your own research. And these national surveillance systems are a good place to get this type of information. So you need to look at the variable in the subset of NHANES 2013 cholesterol data. So let's think about where that would be located. In the module section, we have the National Health and Nutrition Examination Survey, and we have this subset of NHANES cholesterol zip. It is a zip file. So depending upon your operating system, you'll have different ways to open files, zip files. Make sure, as always, that you save it as a jump file, and you will open the subset of NHANES in jump 14. And click open. And this is, of course, a very large file, 8,200 responses, but there is a smaller number of variables here than in the full NHANES. And this is a data set that is representative of some values that we want to see here and use here. To look at the codebook for NHANES, there is not a single PDF codebook. It's a very large data set. You can look at it within Canvas, or you can also link out to Canvas. And we're looking at demographic and laboratory data. We want to find the total cholesterol variable. And so here we find total cholesterol, and you can click on this and it will take you to the total contents here and where to tell you more about this total cholesterol. You'll also see here in the table of contents, the total cholesterol variable is LBXTC, and you can click on that and it takes you to the code book for total cholesterol. So we have this variable here. Let's do a quick analyze distribution on this variable. And we can see here that it ranges from 69 to 813. And if we look at the code book, we can see that there are 7,624 values. We have 7,624 in jump. We can see it ranges from 69 to 813. So it appears that we're dealing with the correct variable. If we go back to Learning Check 5, and we scroll down here a little bit, it's going to ask us things about the gender variable. Well, you can see here, this is gender. So you'd need to go back to the code book for demographics and find out what the gender codes are. we're asked here which values need to be recoded on the outcome variable before analysis, either removed or reassigned to a new value. And again, go back to the code book here, and you can see if there's any recoding that needs to be done. And remember, this is a numeric variable. This is the actual value, so we're not recoding to categorical variables here. So once you do the distribution and jump, you can then assess whether you think the 5-number summary or the mean standard deviation would be more appropriate. That will look at question 5. Question 6 asks, upon careful examination of total cholesterol, you notice there are several outlier variables. So let's go back to our distribution here and change the histogram from vertical to horizontal. So we can see that this is rather right skewed, and we do have a number of large values over here to the right. For your own edification, if you want to look up what normal total cholesterol values are, you can do that and get an idea of how extreme these are. In this, it's asking you to do what's called top coding, this variable at 500. We don't spend any time on top coding in this module per se. You can Google top coding data and learn about what that means. But basically it means that anything above 500 we want to just assign to 500. You don't always need to do this, but there are various reasons that you may, and this is so that you're aware that this is a possibility. There are several ways to go about recoding. Again, I would say do not change the original data column. So we'll go back to total cholesterol, go to columns, go to Recode. We'll see the large listing of cholesterol values here, and you don't have to change them all. You only need to change those that are bigger than 500. So we're going to do total cholesterol 500. And remember, I want a formula column. And down here on the values that are bigger than 500, I simply just need to type 500 in. Now, because this is numeric, my missing can stay missing, and all of the rest of my values will stay the same, and I can simply say Recode. I can now take a look at my total cholesterol and this together, and I can do an analyze distribution on my new value and my old value to see that I am now going from 69 to 500. And if I use jump to select these top 3 that are above 500, you can see they're also highlighted here on the right at 500. You could have also done a find replace. You could have done a formula. There's multiple ways to top code. The Recode in this instance is very simple because there are only 3 values that are larger than 500. So now you could actually describe the shape of the top coded variable and mark everything that's applied. So just do another distribution on our new total cholesterol value. And again, change this to horizontal, and that will be helpful. And we can then now describe what we think the shape of this distribution looks like in jump. So that will take care of question 7. So we want to talk again about using comparing and contrasting the original and the top coded, and what does the 5-number summary change to. Should be a hint for a prior question about the 5-number summary. And then we want to look at the top coded total cholesterol by gender. So we've seen this before. We would want to recode gender into its male and female. You could actually just make it nominal here and use the 1s and 2s, but then you have to remember what the 1 and 2 is. But for demonstration purposes, I'll show you fit Y by X. My gender is my X, and my total cholesterol is my Y. And we bring up this fit Y by X, and then you can ask for the means and standard deviations, and we can ask for the quantiles. This will get you the summary statistics that you need for learning check 5, and then ask the question about what is the statistical technique that would you use for this situation. If you don't know off the top of your head, click on that red arrow and you'll see there's a couple of options here that pop up, and that should give you a hint if you don't know it immediately or haven't checked the notes. It'll go through what is asking for the null hypothesis for this. Now remember, in general, our null hypothesis is no difference, no association, nothing's going on. That's always our null hypothesis in this class. Question 12 wants to know what the alternative hypothesis is. Remember that the alternative hypothesis is always the opposite. If you have no previous knowledge, so I don't know if it's going to be greater than or less than, so that would lead me to be the opposite of equal to, so make your choice there. This asks about independence. So are the males and females independent? What summary statistic would be used for this hypothesis test? So remember, the summary statistic describes your sample. The test statistic is the test you'll be using. So those are two separate questions. Summary statistic describes your sample. The test statistic will tell you what test you're using. Asking about alpha will be divided in half. If you have not seen it yet, there is an announcement here in your course announcements, which I urge you to check every day. There is a hypothesis and p-value help, and it is a PDF that will walk you through basically the different types of hypotheses we'll see and whether or not you will divide your p-value in half. Going back to learning check 5, report the exact p-value. That's to 4 decimal places. If you look in JUMP, p-values are reported to 4 decimal places, so make sure that you use all 4. Make a decision based on that, and then fill in the results from JUMP on the t-value, the degrees of freedom, and the p-value. And you can round the t-statistic to 2 decimal places, answer the question on question 20, and then there is another PDF to review that walks you through some questions, and then you'll go back to your data here, and again, it walks you through the steps for JUMP. Now, in future learning checks, you will not be walked through each of these, but these are the points that you need to hit upon. What is the summary statistic? What is the variability? What is our hypothesis? Then I hit JUMP and it will give me my results. Then I look at my p-value to tell me what decision I'm going to make. And then in your own words, not using statistical language, remember the answer isn't the p-value is less than 0.05. That helps you make your decision. The answer is there either is or is not a statistical difference in these groups, and then describe the difference. And then based on everything you've done in this learning check, make a recommendation to the AHA regarding the gender-specific targets on total cholesterol. If you have any questions about your data or code books, please let me know. Office hours on June 10th also looked at the NHANES code book.